In this video, we will present Simulink import capability, which is new capability available from 19 Service Pack 3. And this works for the Cameo Systems Modeler with SysML and Simulation Toolkit. Here you can see here documentation available. You import it by drag and dropping, and then you get dialog with the ability to choose to import as a value properties ports or as ports. And you can import again once you already had imported and update, and will demonstrate all those capabilities. And for sure, you can execute it as a black box inside of the SysML model. So here we see we have simple Simulink model. We'll create new project and we'll drag and drop this Simulink file directly without any intermediate formats to the SysML model block diagram. It works also for internal block diagram. Here we see we can choose properties, and also we can attach the file to the model, which is valuable way to when we want to distribute the file together with the project file. But you can also add path variables in the Simulink, and then you can run it if you want to keep it in some other place. Or you can keep in the same location as a Cameo project, and then it will run also by default together. Now, what we can add here, we can add type of the ports because it was not imported together in this case. And now what else we can do here? We can actually execute it directly from right click, as you saw. And at the first time the math engine starts, it takes extra time. But the next execution will be immediate, so no time delays on that. So first one, as you can see here, it is time consuming, but this is just like first execution, and it starts in the background, so you will not see it once it is running, and you see immediately it updates the values, right? So the next executions are immediate, it runs in background, right? So it's in the same working environment all the time, You can here run console actions, commands, and that will run the same working environment for Simulink, right? So we see that it works correctly. Now, what we can do, we can actually put it in the context of the system, let's say, and we will do this actually as a sample case to test that it works correctly. So we will put the testing context and we'll say that, okay, we're executing it, and we'll have the constraint block which will check the same logic, will execute in different language, like for example JavaScript, and will perform comparison in order to see that it's passed or failed based on the inputs. So we can change different inputs from one to another, and we see that it actually in both ways calculated correctly. So we put like input 1, input 2 result, 3 properties, and then we create the parametric diagram to test this Simulink model. So we'll right click on our block and we will execute action to create parametric diagram, and this will be part of the parametric equation wizard. Or we can use also just create diagram and create parametric diagram. In the parametric diagram, we'll show all the capabilities here, all the ports and value properties. Now we will add, we'll use this parametric equation wizard to add equation to calculate the same result in the JavaScript because this is the default language. So we'll use results equal input 1 multiplied by 10, 100 plus input 2 multiplied by 2. That was the same as was in Simulink. We can, because we use the same names as the value properties in this equation, so it will automatically map. The names could be also, different, but maybe the similarities, so it will find the similar ones and will map by default. We can change the mapping. And then another equation wizard we will use for the comparison between result which was conducted in one way and compared to another way, result received. So here we can link it and click OK. So we got result comparison here. Now we can run this model and see that it executes correctly or not. So we see it's green because it is correct. When we have zeros, zeros are in both ways zeros. Now let's change inputs and see how that changes the result. Still, you see the result is correct, right? Doesn't matter that we have different input. The result is equal in both ways. Now we can exercise this, automate in an automated way, or we can just save as, for example, instance, and then create multiple configurations of the inputs and see that it's still running the same correct way. Why it would be useful, for example, because maybe we will receive it, again in the future, and then we will have the set of data which we check based on our imported solution. So that's like very simple Simulink file, but it could be more advanced one, and then we might want to check just because something could happen, maybe someone exported incorrectly, maybe someone, imported wrong one. So why not to check, and be sure that it's actually passing the test, correctly. In this case, it is checking with the instances, and we will create the column for the constraint to see that it's passed, and then we'll create multiple instances and we'll set multiple input values to be sure. So any change in Simulink file, if we'll change the logic, so it will perform incorrectly based on this test, so we will know that it's actually doing something else, so we can check that in this way. So we see here both ways it works. So now next what we will do here, we will re-import Simulink file. So we'll go to the block diagram, we'll take the Simulink file, new one, we will update it here in this model. So we change to 50, and then we'll change another gain to 10. So if inputs are, for example, 1 and 1, so it will be 60, right? Yeah, so we put 10 here and save it. And we'll re-import by drag and dropping. So here we don't show, but we actually also kill the current works environment, which is in headless mode already running. So in command line, we wrote kill MATLAB. And now when we re-import, you saw that we are able to attach the file, but we are not able to kind of ignore existing ports. We just update them. If something new happens, we can also see those new ports. We can decide to show them. And here we will change the logic. So we'll change the logic because if we will run now with that current logic, it would fail the test. So we change the logic and we'll re-execute those tests. You see, we are running without behaviors because that executes the Simulink model as a black box, don't have behavior inside. The behavior is inside of the Simulink model, but but it's actually another thing, how it executes it. It executes it as a inputs and as result. Now, next step, what we will do here, we will use import to activity diagram. So here we see we drag and drop to activity diagram. And in this case, we are using next version of the Cameo. This will be released in November, and this is new capability which allows you to import to activity diagram. It's not available in current 19 service pack 3 or 4, but it will be available. So here we see here internal release where we will set up this model to demonstrate and to test the Simulink import with the inside of activity diagram. So it was enough just to drag and drop this, and we received automatically the action calling this Simulink file, and now here we will execute it in a moment. So we are assigning the inputs, and also will capture result. So for example, result assigned to the variable C. This C will be like runtime variable, which we name the pin in order to pass that by that name into this opaque action, and the input will come from here, right? And then we'll do some delay here just to see the result, and like say 20 seconds, and then we'll run this execution. Because we have some result variable which is not runtime variable, we need to define it. So for that purpose, we will create a block and move our action inside of the block as a classifier behavior. In that way, it will run in context of the block, so we'll see the value properties of that block. So now we can execute this block, and activity will run automatically because this is classifier behavior. First behavior of that block automatically assigned as classifier, but we will create also requirement to check that result is correct. So we can say, for example, result is equal to 102, and this is because that was the Simulink file before update, right? So this we imported that older version, right, with the gain 50 and 2, right? So that's why we set like this. And also we'll turn on the automatic text parsing and conversion to constraint capability of requirements. So we'll go to options, project general, and we'll go here to turn on the requirement terms glossary. And here we see that it converted this text into the constraint, and we can now execute, and we'll get result that it's actually not only that it passes through, produce result, but the result is actually automatically checking that it is constrained by the requirement text. 102 in this case, equal to 100. As you saw, this capability here of signal passing as a value through the connector, this is new capability. Again, it's in this pre-release version. It's not available yet. November will be released. So we can see the type. Again, we saw result coming out, and we delay, and result is incorrect. Why it is incorrect? Because the inputs were 5 and 6, and the result was expected 102, which with inputs 1 and 1, right? So if we'll put 1 and 1, result would be 102, and then it will say it's okay, it is correct. And you saw that there was some delay, right? Activity diagram takes time to execute, but this is only because we use the delay as animation speed. If you run it without delay, it would give immediate result. Now, what we could do here, we could actually test it also, by creating another opaque action, which we will perform, which would perform a comparison, same as we did previously, right? So let's do this. Let's create another result, and we'll compare between the inputs, and let's create inputs, input 1, input 2, and let's compare and check that result is correct. So result 1, result 2, input 1, input 2, and let's see that it's actually correct. So let's do that in activity diagram. So here we saw how fast it executed. It was immediate, right? And now let's do this with the additional actions. So we create another object flow. We'll name those pins because by name we can get the runtime variables which we can use here. And the output here. So output will go as, for example, C, and it will be result 2 updated by that runtime variable. So this is the way to get this runtime variable. We pass by this name, and we can get by another name, but in this case doesn't matter, so we can use the same name, and then we'll synchronize here. So we'll synchronize just to have the same result before the entering to the delay, right? And we can see here the two inputs, and we have no initial flow because the actions don't have the input, so they will execute immediately. But there are some problems with this requirement because now we just compare, so we don't want to get the result specifically. We might input different values here from different input 1 and 2. Now what we'll receive here is just different results on result 1 and 2. Actually, same results for 1 and 2. There are some other problems in this activity diagram. What we will see in a moment is when you execute here, it fails. What was the reason to failure? As you can see, terminated, is that we didn't split the flow, right? So the A and B, they produce 2 tokens. Unfortunately, they produce just 1 token, so we need to split that flow. So to split the flow, we will add, as you can see here, slowly, we see that it passed here. Okay, it passed here. So we are debugging and we see that, okay, it passed here. That's okay. But another one didn't got the token, and that's failed because another one will never produce the result. So we need to split the flow. We added this fork here, and we assigned that in output to this place here again. The same for another one. Fork and output here. We did mistake, output here. Okay, so now let's run this one. We see output here, goes here, it splits, now here, comes here, it again splits, both goes out, both goes out. Here, input comes here, travels here, and the result is received. So equal result, right? We could run this, with some testing loop, that we change by 1 every, iteration, and from -1000 to +1000 with different, step size, and that could be done, just by 1 or like by random numbers, using Monte Carlo kind of capability by randomizing, not Monte Carlo, but by randomizing the inputs and checking the result, right? Cameo has built-in random function generator for uniform and normal, but you can use also MATLAB random function generator to produce their inputs and so on. JavaScript random function generator. There is another video on that topic, And because activity really don't take time to execute, we just slow down it to see that flow. So this checking of thousands of values will not take time, right? So here we see that the requirement was that result is equal. We use for that constraint result 1 equal result 2, and we satisfy the requirement with constraint, so we got result